Hello guys, Mr. Yi here, and we're going to be making the second video on the test on vertical projectile motion. This is the second part and final one because it's going to be 50 marks. So the question is question 3. Last time we did question 2. Here you can see we were solving some questions that were quite challenging, I think quite interesting. We're going to go to the question 3. Now this question said, a ball of mass 100 grams is drawn from a height of 2 meters from the ground. After bouncing back up, the ball reaches a maximum height of 0.5 meters. Ignore the air friction. 3.1. Explain what is meant by projectile in physics. Use only equation of motion to calculate the time taken by the ball to reach the ground and time taken to reach the maximum height of 0.5 meter after bouncing. Calculate the average force exerted on the ball if the collision lasted 2 times 10 to the minus 3 seconds and sketch a velocity times graph. And there is something you have to sketch. Is the collision elastic or inelastic? And explain the answer. So we're going to start answering this one, and the first one is a projectile. So let's answer the question here right now. Okay, so what is a projectile? A projectile is an object, and that is quite important word because people confuse object with motion. It's an object which has been given an initial velocity and then it moves under the influence of gravitational force only. And that is very important. The only force acting is the gravitational force. Okay, so this is a projectile. So we're ready for the next question. The next question said use only equation of motion to calculate the time taken by the ball to reach the ground. Okay, so we're going back. A ball of mass 100 grams is dropped from a height of 2 meters from the ground after bouncing back, and then it bounced. But that is the second part. So let's go to this part of the question and let's, as usual, write the data. So now we have to look for a formula which has a time. So in this case, I think this one is the better one. You can always calculate final velocity first if you want, but I think with this one, you don't have to do extra calculations. And then in terms of marks, most of the mark will be given by the formula and substitution. So the calculation will only carry 1 mark, which is obvious. You do need, but in case time is playing with you. So this one is 0 multiplied by time. And this is the answer, guys. It's quite simple. It's not that bad. That is the way I found to be the shortest. However, if you want, you can calculate the velocity first and then use another formula. We didn't write the acceleration here in the data, but I recommend you to do that. And it's 9.8 positive because we say downward is positive and it's the motion downward. Now the next question said calculate the time taken to reach the maximum height of 0.5 meter after bouncing. So for 3.2.2, I want you to see something that is happening here. An object is being dropped from certain height to the ground, which is 2 meters height. This object is being dropped, and then at the ground the object bounces back. This one is 2 meters high, and the object bounces back to a height of 0.5 meters. They want to know how long it took to reach that point of 0.5 meters. Remember, here the velocity is going to be 0. Okay, now in this case, the first thing we're going to do is to calculate the initial velocity, and we're going to be working with this part of the motion, guys. So it is as the object is moving up, we're going to say up is positive. So for that part of the work here, what we have is that the displacement is going to be negative 0.5 meters. We have acceleration due to gravity is equal to up positive, so this one is positive, sorry. Acceleration due to gravity negative 9.8 meters per second. The final velocity is 0, and we are going to look for the initial velocity. We need the initial velocity before we can calculate the time, because all the other formulas will need the initial velocity somehow there. So if we go here, we have now that the final velocity square is equal to initial velocity square plus 2 times acceleration multiplied by the displacement. We're going to use this formula to calculate the initial velocity. And here is the answer for the initial velocity of the object. So this is the velocity with which this ball leaves the ground, but that is not the question. The question is to calculate the time taken to reach the maximum height after the bouncing. So when we have the initial velocity, then we can use any formula. Final velocity equal to initial velocity plus acceleration multiplied by time. And we're going to stay with a positive for this entire part of the question here. Here we say up is positive. Okay, so if we do that, then we have that final velocity 0. And the answer here is going to be 0.32 seconds. Okay, so here is the answer, guys. That is the answer for the time taken to reach the maximum height after bouncing. That is the question there. Time taken to reach the maximum height of 0.5 meter after bouncing. Now the next question says calculate the average force exerted on the ball if the collision lasted 2 times 10 to the minus 3 seconds. And for this one we have to go all the way to Newton's law in terms of momentum. Okay, so this is question 3.3. Alright, so now for this one we have new data here. So we have to add the mass, which is going to be 100 grams, but remember we cannot work in grams, so it will be 0.1 kilograms. Okay, now for this work, if we go back to this picture here, we need the velocity with which the object reached the ground, and we need the velocity with which the object leaves the ground. This one here, we have it because we just calculate the initial velocity of the object leaving the ground, but we did not calculate the velocity with which the object reaches the ground. So the first of all we're going to do is that one. Okay, so as it moves down, so what formula we best use here? Final velocity is equal to initial velocity plus acceleration multiplied by the time. Okay, and if we substitute here, I get this is equal to 6.272 meters per second. That is the velocity with which the ball reaches the ground. Now the other option is to use the other formula, or we can use the other formula, and I want to show you something here, just in case somebody use the other formula here. Okay, which is this one here. If any of you guys use this one, you will see the following there. Yes, if you use this one, then the answer is going to be 6.261 meters per second. Now note the following, there's a tiny difference in the decimals between that answer and this answer. Now why is that so, you may ask? Okay, here if we use this formula first, here, this answer we got at the beginning was a rounded off answer to 2 decimal places. The final answer I did round it off, and then I substitute here an answer which is rounded off there, and that is why the tiny difference at the end. So to me, this one may be a little bit more exact because I didn't round off any answer. I didn't have any answer, but I want you to notice that it's a tiny difference if you use any of those formula in the decimals, and that tiny difference coming from this one, that it was rounded off when we calculate in the very first question here. This answer here at the end was rounded off, and that is why you get that tiny difference. So we're going to stay with the final one because I think it's a little bit more accurate. But if you were with this one, you will not have an issue, guys. It won't be a big problem here. So we have now the final velocity and we have the initial velocity. So applying Newton's second law in terms of momentum, we have that this is equal to change in momentum divided by change in time, and you carry on mass that multiply the final velocity minus the initial velocity divided by time. Right? And when you substitute, be careful with the direction here. We're going to keep in this specific question down as positive. I didn't write it there, not to worry, we can say now down as positive. I did say it, but I didn't write it, so let's say it. And if we do that, then here when we substitute here, we have that F net is equal to 0,1 bracket multiplied by the final velocity, which now the final velocity is not the same velocity here, okay? I want you to notice that one. Object is moving down, reaching the ground. This velocity, let's picture this one differently. This velocity with which reach the ground, this one is 6,261. This one is the one that is going to be initial here because it's the velocity with which the ball reaches the ground, and then it's going to leave the ground up with a velocity which was calculated here in this question, which is this one here, guys. This is the velocity which with the ball leaves the ground. Okay, so this one here is 3,13. I don't want you to get confused with the final that I wrote here, and the final of this formula is a different thing. This one here will be initial because is the velocity with which the ball reaches the ground. So is initial, and the velocity of which or at which the ball leaves the ground, this one here will be the final. So that is very important to notice because they change. Whatever was final before now is initial, and so on. Okay, so be careful with that one. So here now we are. What is the final going to be? The velocity with which the ball leaves the ground, which is 3,13. And if we set down is positive as it is here, then that one is negative. So it's minus 3,13 minus the initial velocity, which was the one we calculate here. You can see there is the velocity with which the ball reaches the ground is 6,261 positive, but the minus at the front divided by the total time. They giving you the time that the ball is in contact with the floor, 2 times 10 to the minus 3. So we are going to substitute that number here is 2 times 10 to the minus 3. And then, guys, is just calculation here. And when I calculate, I get an answer which is a negative 469 Newton. This is the answer I get. What does the minus mean? This minus here means upward because we say down is positive. So if the negative is negative, it means upward. So it could be live like that, but let's write the direction inward because they like direction inward here. So it's 469.5 Newton upward, and that, guys, is the final answer for this specific question of the force. It's not that bad, it's an average force, not net, but if you write net, it should not be a problem here. okay? But it's an average force what they want. Let's write average, let's quickly write average because you never know. So let's write average. They want the average force, okay, which is the same at the end here in this case here, okay? So let's write here average and average stop there, okay? I'm going to leave it like that. So this one is the final answer for that specific question. And we're going to a very nice question, which is the graph. The graphs are very important because are quite confusing. They are quite confusing. In this case, velocity times graph is going to be velocity times graph, and we need the velocity values, all the velocity values, time taken to reach the ground and time taken to reach the height of 0.5 meters after bouncing the first time. So we're going to start with the axis as usual, and we're going to take down as positive. So now, important, the initial velocity of the object when it started moving was 0. So starting from 0, the object moved all the way to the ground, as I'm going to show here, all the way to the ground, reaches the ground with a velocity with e is going to be 6,261. We have it there. So because we said down is positive, the final velocity then must be positive here. This one is 6, and is what we got the 6,261. How long it took for the ball to reach the ground? It was calculated in the very first question of all. It was 0,64. Remember 0,64 after being rounded off. So this time here was 0,64 seconds, and the ball was the straight line. It's a straight line up to that point, okay? So this here is a straight, beautiful line for the first part of the motion. That means this here is from release point, from starting to ground point, or from release point to the ground point, it doesn't matter. Now, what happened here? They said they are telling you in the question that the ball stays in the ground for some time. It is not immediately bouncing. It stays in the ground for this time, the guys. So that is important here. So it's going to stay in the ground for a little bit. It's going to stay there for a little bit in the ground. I'm going to do this blue one so you can see the difference. And it's going to change direction because it's now going to bounce back there. It's going to change direction, but it stays there a little bit with an initial velocity which was 3,13, but it's negative because 3,13 upward. So it's going to be negative because we say down is positive here. So it's went all the way here down to 3,13 negative. That is the initial velocity of the bouncing. How long it took to reach the maximum height? And now I want you to note this one. Be careful there, because now this one is we're going to speak about the time in here. Now the time that it took to reach the maximum height was only 0,32, but 0,32 from the starting from the bouncing. So we have to get the total time. However, without writing the time yet, we can't write the shape. So it go all the way there to the 0 point. Okay, we are going to now most definitely write the time. We are going to write the time down. This one is the total time. That is the total time, okay? But know the following. Those two lines here must be parallel lines. They must be parallel. I said this one all the time because they have the same gradient. And this one is almost done. So we have most of the marks here. The only thing we need is the total time, we are going to do real fast. Total time will be equal to 0,64 plus the time it was on the ground, which was 2 times 10 to the minus 3 plus the time to reach that height, which was let's quickly look here. I done 0,32 plus 0,32. So and I get an answer of 0,962. So this is the total time, which means here 0,962 seconds. So that is that time. Now the confusion here is that some people will write the 0,32 instead of 0,92, but it must be the total time, guys. And saying that this is the final part, the final part say is the collision elastic or inelastic, and explain your answer. But that one is quite easy. If we come here, we can see that in the graph, we go to the graph, we can see that the velocity with which the ball reaches the ground is not the same with which the velocity leaves the ground. So the collision between the ball and the ground is going to be inelastic. Why? You can see the same object, the same mass, but the velocity is changing. So the initial velocity and the final velocity is not the same, and therefore the kinetic energy is not the same. So for say this one, I just going to say that the collision is inelastic, velocity initial is different to velocity final. So kinetic energy or total kinetic energy is not conserved. It's not constant. I hope you understand. I don't want to write it too much or add another page. But here is the answer for this question, I hope. But now, saying that, I want to rectify some little mistake here, which is not that big, but is a mistake. A mistake must be fixed, guys. So here I said that acceleration is 9,8 meters per second, which is not true. It is meters per second square. Be careful with those kind of mistakes. This one is in the data, which does not carry marks, but it is wrong. And if it's wrong, it must be fixed. Now here I also said meters per second. I don't know why I say that. It is wrong. I'm doing the videos very early in the morning, and maybe I'm still a little bit sleepy. But you could see here when we started, we did said 9,8 meters per second square. The unit for acceleration is meters per second square. But guys, thank you for watching. I hope you understand. I hope it helped. I am really sorry about that tiny mistake. I apologize. I'll see you next time. You can write messages, comments, suggest, subscribe for the channel. I'll see you later on. Mr. G here.